Okay, so on Monday, we talked about the beginning part of chapter 11, which is solving equations. And one of the things they did at the very, very beginning of 11:1 was practice in simplifying. So what I want to do is show you that this one problem and then maybe a few others, and then we'll move on. So as far as I could tell, this was the problem. And the thing I want you to see is there's 1, 2, 3, 4, 5 terms. And the terms, and this is the word I'm using, terms, T-E-R-M-S. Each term is separated by either a plus sign or a minus sign, okay? And so if you're multiplying or dividing, you're on the same term. So what you notice here is 2 of them were X terms. And so that's what caught my eye at the very beginning. And remember the commutative, go ahead.
This isn't the problem. There wasn't a +1 after -2, it was +1. It was just +1 over 3x.
So take this one away.
Yeah.
Okay. So there's 4 terms. 1, 2, 3, 4. Still, these 2 are X terms. And so I'm tempted to put that first, 2/3 X plus 1/3 X. Okay. In other words, I'm going to deal with these 2. Then the other 2 are like terms. This one and this one, they're both plain numbers. So that's subtract 2 and add 7. So these 2 could go together. So 2/3 and 1/3 make 3/3. And 3/3 is really 1, isn't it? So 1x, so you would write it as 1x. The simpler version would be just x. Then this here, these 2 are plain numbers, which are also alike. And so a 7 take away 2 is 5. Now what you have to do is put a sign between them. You can't just say x5. This is plus 5 more. So the x terms added to 1x or x, the plain numbers added to 5. You needed this symbol here between them. And that's how that would add. Now, I can't remember who asked, was going to share the screen. So I'm going to go back. Who was it? And
Me, Xavier.
go ahead and share your screen and we'll look at those.
Okay.
So did you hit share screen yet? I have not seen it.
Yeah, I hit. Hold on.
Sometimes there's a delay.
Okay, now I get it.
Okay, there we go.
You see them?
Yes, I can. So pull up the problem that gave you trouble. Oh,
Yeah.
I was pleased with something else. And this particular thing, the main part is the formula. And the formula for this is on the second line. It's 72 subtract A divided by 300. So that's the formula for the temperature. So this is temperature, the temperature formula. Now, all you have to do is write down 72 minus A over 300. Then it says, find the temperature when you're at 12,000 feet. That means that's the altitude. So in our case, A was 12,000.
Oh, okay.
So what you do is, I
Mhm.
can show you on paper, but it's 72 minus, put 12,000 where the A was, and 300, and I'm gonna, if you would stop share, I'm gonna show everybody what I was saying. So this was the formula that they gave. And A
Okay.
was altitude, and this was actually, the whole thing was about temperature.
Mhm.
Then they said, you're at the height of 12,000, which you had to assume was the altitude. So this formula, you can't come up with an answer until you know the A, and they told it to you, although they didn't specifically say its altitude is 12,000. They said the height was 12,000. And so this is the computation you need to do. Now notice I like to simplify things. There's 2 zeros here. So I like to take out back zeros when I can, so my life is easier. So 3
Mhm.
into 120 is 40. So 3 into 12 is 4, 3 into 0 is 0. So I took out those zeros. So my answer is 72 minus 40. So my temperature would be 32. So in each one of those problems at the very end of 11.1, you could find the formula. And so it was usually, on the second line, find the formula. Then at the very end, they told you what number to put in for the missing letter. And then you carefully simplify it. So you had to simplify this. 72 was good. You had to simplify that and then get your final answer, which you turn in like that. Is that okay?
Yes. How about the second one?
So you're gonna have to share your screen again.
Yeah, let me show you. How about this one? A
Same,
water.
same
The
thing.
same.
The formula is on the second line.
Okay. So I multiple 3 by 13.
So 7 plus 3G. So they were talking about it, but the formula is right there at the end of the second line. 7 plus 3G, and G stands for gallons of water, right? Then it
Uh-huh.
says, find the bill for 13 gallons. So instead of G, you would go 7 plus 3. And when you get to G, you put in the number 13.
So I multiple that one.
Yes. So
Okay.
3G means 3 times G. So that's
Mm-hmm.
3 times 13, which is 39.
Mm-hmm.
Added to this 7 at front, looks like whatever it is, 48? No, 46, whatever it is. Okay?
Okay.
Okay. All righty, that was good. So it's word problems, but basically they gave you a formula. They gave you the number that would go in for the missing letter, and that's all you have to do. Then you just simplify it.
Even this one, the same formula, right?
Yes,
I'll
same
look the
thing,
same.
that one. See the formula 3,900 plus 25T, all
Mm-hmm.
over 100. So the missing letter is T, right?
Uh-huh.
You go to the very end, it says, find the bill for 12 minutes. So instead of T in the formula, you put in the number 12. So you're
Okay.
forced to go 25 times 12, but then
Mm-hmm.
the computation, you've got all the numbers in place now,
Okay.
okay?
Yes.
So if anybody needs more help there. So you're gonna hit stop share, and I'm gonna
Okay.
go. So we can do some more a little
Okay.
bit later, but I wanted, that's good, because now we know some of the problem.
Mm.
Now, I had started with 11.3, and I want to get this, this new material out of the way first, and then we'll still have some time, I think. So 11.3, what I did already was I did a few problems where, let's see, let me go, 1/5 x equals -6. And so the 1/5 is multiplied to the x, and so you're trying to get rid of 1/5. So what I said on Monday was dividing by 1/5 and dividing by 1/5 is making it more messier problem. The simpler version to get rid of 1/5 is to multiply by the reciprocal of 1/5. Now, leave the x alone because that's what we want to keep. But if you would multiply by 5/1, then you would have to do the same exact thing over here. But what happens when you multiply by the reciprocal of this? The 5s cancel right out, and you're left with 1x. And that's the simplest way to do it when there's a fraction multiplied to the letter. Over here, and there's my equals. Over here, I have -6 times +5. That's -30. That is the simplest way to do it. Now, you can try other ways, but as far as I can tell, that is the simplest. Let me try, I wanted to try 2 other problems I see here when there's negatives involved. Let me see. Reminding you about the rules for negatives. And so this one here, it's 7 times x. Now, there's no sign there, but you could put a dot there to remind you. But to get rid of 7 multiplied, you could divide. So if you divide by 7, you would divide by 7. So 7 divides by 7 is 1x, and we would just probably say x. But this one here is division, and 1 negative makes it negative. So 35 divided by 7 is 5, and the 1 negative makes it negative. So I wanted to remind you, in division or multiplication, 1 negative makes it negative. Just like up here, when I had negatives times a positive, it's 1 negative, so it's negative. What I wanted you to see next is this. Let's see if I can find it. Okay. Here's my x. Here's the number that has to go. This number, -6, is multiplied to x. You don't have to say so, but it's true. And when you get rid of this number, you can't just divide by 6. Because this is negative and this is positive, that would end up negative. What you have to do is divide by the same number and the same sign. So if we divide by -6, the 2 negatives will make it +1, and then the x will be left. So I'm going to do it to both sides, but I want you to see when I cancel -6 divided by -6, I'm going to put it on the side. That's 1, and it's +1 because 2 negatives make it positive, and 6 divided by 6 is 1. So this ends up being the same number. That's the plain x. Now over here, I've got 2 negatives. Now 42 divided by 6 is 7. And the 2 negatives in division makes it positive. So the trick here is when you had a negative number multiplied to the x, you have to divide by the same number and the same sign. That's a kind of a common mistake I see. And so I wanted to show you that particular one. Now, fractions are always a problem. I'm gonna okay. This one here is a fraction multiplied to x. And the simplest way to handle it is to multiply by the reciprocal. So I'm going to take this and I'm going to multiply by the reciprocal. Now, the reciprocal of 3 over 5 is 5 over 3, but it's also negative. So the negative carries so that the two negatives stay positive. So once I decide what's going to do it for me, I run over here and do the exact same thing. And that's why I changed the color here. I've multiplied by negative 5/3, multiplied by negative 5/3. So the 5s cancel, the 3s cancel, the two negatives make it positive 1. And that side is all clean and good. This side here, there's one negative in this multiply and divide, and the rules for multiply and divide are the same. So one negative is going to turn this answer into negative. I need to cancel this right now while I have the chance. 3 goes into 3 once and into 9 3 times if you cancel that way. 5 and 10. 5 goes into 5 once, into 10 twice. And what's left is 3 times 1 over 2 times 1. So it's minus 3/2. Now, if you learn to do this, and I'm going to just ignore the negative for the moment and just focus on the numbers, you might have learned to do this as 3 times 3, which is 9. 10 is 2 times 5. So if you broke this down, the 9 into 3 times 3 and the 10 into 2 times 5, then your canceling is just 1 for 1. And this 5 and this 5 hit the dust. And all that I have left is 3 times 1, which is 3, and 2 times 1, which is 2. So there's my answer, 3/2. The one negative yeah, the one negative makes it negative. And so there was one negative. And so I just wanted to remind you of the different ways to cancel. So this is your answer. And so you may need a little more practice with these than the others. But I wanted to show several examples. Now, I've got something new. 3x minus 1 is 5. This is the very first time we looked and found the x, which is on the left side of this equation. And there were actually two things that had to happen. You had to find a way to get rid of the 3, and you had to find a way to get rid of the negative 1. So I call these problems two-step. It's going to take 2 steps to finish it. And the order in which you get rid of the 3 and the negative 1 makes either something easy or something hard. So it's well worth it to pay attention to the order. And so what's going to happen each and every time, here's the x. I'm going to get rid of this number first, the number that's either added or subtracted onto the x. And so this is going to make it easier. So to get rid of negative 1, we already know what to do. We would add 1 to this side, and here's the equals. I'm going to add 1 to the other side. So negative 1 and positive 1 go to 0. And what's left here is 3x. when we put this together, 5 and 1 makes 6. Now we've got a multiplication. This is 3 times x. So the simple thing to do is just divide both of the two sides by 3. This is 1x, which is x. And 6 divided by 3 is 2. If we do this in the other order, we're going to end up with fractions all the way through this problem, which we do not want. It's well worth it to always remove the single number first, then the number on the side with a letter that's either added or subtracted on. Get that out of the way first. I'll show you a couple of other examples so you can see what I'm saying. 7x minus 5 is 30. I want to get rid of the single number first, the number that's not attached to the x, but just -5. I'm going to add 5. Add 5 to this side, add 5 to that side. Subtract 5, add 5 is 0. And so what I'm left with is 7x. What I have over here, I have a 30. I have added the 5. This is now 35. And you can see this is going to go smoothly from here. This is 7 times x. I divide by 7, divide by 7. X is 5. Any question? I'm going to keep doing these until I run into some more problems.
How about another way? Like I leave 7x here, so I took -5 to add 30.
Yeah,
Can I do like that?
that's what I'm doing. In other words, I'm adding 5 to get rid of the -5, and I'm adding 5. So I end up with 35, right?
Mhm.
Hmm.
Mhm.
As long as that's what's happening. This is just one way to show it. There may be other ways. The book tends to put the +5 here and here. I like it
Yes.
below. I just find, it's easier to spot what has to happen, but it doesn't matter whether you put the +5 there and put the +5 there. I just find it easier this way. Okay, so you can do it either way.
Okay.
Okay, good. So let me see what else I've got. Let me do some negatives. Okay. This is still a two-step problem because I've got the -11 to deal with and I've got the +4 to deal with on the same side as of the equation. I've got to get rid of the +4 first, like it or not. So I'm going to subtract 4 from this, and I'm going to subtract 4 from that. So the plus and the -4 is 0, and I'm left with this over here, which is -11a. You have to put these together. So this is where they're written like this. This is -29, and then some more -4 more. So when you actually add these, and this is -33, which is really nice because now it's going to divide well. So this is negative and then more negative, so you're adding. So what I have to do, I can't divide by 11. I need to divide by the same sign. So that would be -11 on this side, -11 on that side. So the -11 and -11 go to 1. And that's 1a, which is a. The two negatives make it positive, and 33 divided by 11 is just plain 3. Okay, this is your best bet. And I'm going to try one with a fraction. 3/4 x subtract 2 equals 7. I see the fraction and I don't like fractions particularly, but I realize this is a two-step problem because I've got the 3/4 to deal with and I've got the -2 to deal with, I'm gonna do the same thing every time. I'm gonna get rid of this number that's subtracted from the x. And so I would add 2 to get rid of that and add 2 to get rid of that, or to be the same. That goes to 0. So what's left is 3/4 x. And over here, I have plain ordinary 7 plus 2 is 9. Now I've got that problem of the x multiplied to a fraction. And you know what I've been doing all along. What have I been doing?
Divide, multiple by 4/3.
Multiply by 4/3. That's what I would do. And so everything cancels down to 1x. And over here, I'm going to put my 9/1, and there is this, I can cancel it here, one way or the other. Whoops, that's a 4. No, it's a 3. Holy mackerel, I need caffeine. So 3 times 4 is 12. Okay? So this messy thing that started out, I've got my answer, and that's what they're looking for, is what was the x in that
Did
equation.
it a different way, but I got the same answer.
What did you do?
So what I did was I did the first thing right. I added 2 to the 7 on both sides, and then I got 3/4, and then the 9 on the other side. But I didn't change it to a fraction. I pretty much changed the fraction into a decimal and multiplied
okay.
it by 9, and then got 12 as well.
Okay, so yes, so that would work because you got rid of the 2 first, and that was critical, so you didn't have too much of a mess. And then this was what, 0.75?
Yes.
And that would, then you would
And I
divide
multiplied.
both sides by 0.75. Why does that work? Because if you can turn a fraction into a exact decimal, not close, but exact,
Mhm.
then there's no reason this would not work. This would work.
Okay, got it.
Yeah, so the problem is when people turn fractions into a decimal, but it's not exact. This is exact. And so if it's one of those decimals that goes out forever, there's no way you're going to handle it.
Okay.
It's going to be off. And so you're better to stick with fractions when you have decimals that go out forever. But this
Okay.
one being exact, it stopped at 0.75. That was the end of it.
Mm-hmm.
No problem. So we're starting to get flexible here. You see what I'm saying?
Yes.
We're like, oh, I can do it a different way. Okay. And here's my statement about that. If you can do it a different way and it's going to work for you 100% of the time, I have no problem. But if your way only works part of the time, forget it. Because there are some things you can do wrong and still get the right answer. That's nothing you want to be involved with. That's just a disaster. So let me see. Okay, I think that's pretty good. I want to see this one. This is another version. And then I'm going to write down. Okay. Here's an equation. There's one more topic, I think. But here's one where this is a mess and this is a mess. And so your first job always is to clean it up and combine like terms. And these two are a match. They're both x's. So 2x and 3x would be 5x. And then it's -5, which there's nothing to do for. But over here, 7 and 3 makes 10. So your first step was to clean it up. And there's nothing more I can do with this. This is an x term. This is a plain number. This is a plain number. Now we've got a problem kind of like what we were just doing. We've got a 2-step problem. And so this 5 here, the -5 needs to go first. So I have to add and I have to add. So 5 and -5 go to 0. And what's left is my 5x. And over here, I've got 15. One more step, this is multiply. So I'm going to divide by 5, both sides. That leaves me with 1x, and there's my answer 3. So what was different about this problem was that it was kind of a mess to begin with. And so the very first thing I did was I said, oh my, I could make this a lot simpler and make this a lot simpler. And so you want to do that first. Can you survive a problem where you leave it a holy mess? Yes. Is it asking for trouble? Yes. We don't want to ask for trouble. We have plenty already, don't we? So let's see. All righty. So I think that will take care of 11.3. And there's one more section in 11.4, and I want to spend the rest of the time on that one. 11.4, they start out with this one. And I think based on what we've already done, you have a sense of what needs to happen. This is step 1. Simplify, I'm going to call it. And simplify includes getting rid of parentheses. So this is where we distribute the 3 to both of them. And so that seems like a logical step from what we've been doing already. So it's nothing really new. This would be 3x plus, this is 3 times 2 is 6. And that's equal to -9. I look at the problem as it sits right now, and I have a 2-step problem. I know what to do. I'm going to subtract 6 here and here. So the plus and -6 go to 0, and I'm left with my 3x. And I have to combine these. It's negative and then more negative. So I'm adding 9 and 6. It's -15. I then divide and divide. X is -5. Okay, so the only thing that was different was we had to deal with the parentheses first, and then we could move on. Now, I've got one more basic idea to show, and then I can write a summary. So let me get this right. This is 4a plus 5 equals 2a minus 7. This is the first time we put this type of problem on the page. When I go to locate my letter A, I notice that A is on the left, 4a, and A is on the right, 2a. This is a situation that will never resolve itself until we get the A's on one side left or one side right. And so we've got to deal with that. Now, step 1 is always to simplify, but this is simplified. It's a 4a and a plus plain 5. This is simplified. This is 2a and then subtract 7. They're both simplified, but the next major problem is the fact that I've got the letter A on both sides of the equation. This requires immediate action. Now, I could move the 4a to this, but what I typically do is pick the smaller one. This is the lower one. This is 2a would be, in this case, would be the lower one. This is considered positive because there's no negative on it. So if that's positive 2a, I could get rid of it by subtracting 2a. If I subtract 2a here, I've got to subtract 2a here. So 4a, take away 2a would be 2a. And then the +5 is just copied. Now, the 2a minus 2a is 0. And that's what I wanted to happen. But I can't ignore the fact that there's also something right here, which is -7, so I'm going to bring it down. I've now solved a major problem. It's not done, but I've gotten rid of, get the A's on just one side now, which is what I wanted. This is now the two-step problem. The 2 and the 5 have to be dealt with. I will deal with the +5 first by subtracting 5 both sides. 5a +5 minus 5 is 0. I'm left with 2a. And then -7 and -5, you keep going more negative, that's -12. One more step, this is always the easy step, divide by 2. 1a is a. 1 negative in division is -6.
Professor Patterson,
Yes.
the reason why you were able to do that is because even though the number had a variable, it still falls into the category of it's a like term. So you can subtract or add it away
Yes.
from each other.
That's
even
right.
though it's on opposite side.
Here, yeah, they were both a terms, so it's 4a,
Yes.
take away 2a is 2a.
So being a variable doesn't change that.
No,
Okay, thank you.
A's are, it goes with A's and B's go with B's. That kind of thing. All right, let me see if I can't find us another one. Oh my, I don't want to do that yet. Let's see. All right, let me find another one similar. This is 12x plus 3 equals -2x plus 17. Both sides are simplified. So this is one term. So when you're multiplying, you're on the same term. This is the other one. This is 1, this is 1. So I want you to see the terms because they're like little units. But the trouble I see straight off the bat is this is 12x and on the other side is -2x. And I really need to get my x's together. And
Can I
so-
ask a question?
yes.
For the last problem, you started with the 2a as opposed to the 4a, and I figured we'd go left to right as we've always done. Is there a reason why you didn't go for the 4a first?
It avoids negatives. And in general, if you see a 4a and a 2a, and you have to choose which one you're going to move or get rid of, the advantage of getting rid of the smaller number is that you avoid negatives.
Got it.
And so I'm trying to do every single thing that will avoid the pitfalls
Yeah.
that people have.
Got it. Thank you.
You could still do it both ways. I'm not saying that. But you can, but I'm trying to get you to do the path of least resistance. Do you know?
I see. Okay.
Okay. So this one is 12x and this one is -2. This is clearly the smaller of the two. So I'm going to choose to move this one. And because it's negative, to get rid of it, to make it go away, I have to do the opposite. So that the -2x and the +2x will just gone. But once I decide to do that, I have to come over here and do the same exact thing on both sides. So what happens over here, 12x plus 2x make 14x. And this is +3 that I can't ignore. But when this is what I intentionally did, I cleared the x out from this side. And so that's 0, but what I still have is the number 17. Questions? So now it's a two-step. The 14 has to go, there's the X, the 3 has to go. The 3 is first. I'm gonna subtract 3 because that's add. I'm gonna subtract 3 to match it. The plus and minus 3 intentionally are gone, and what's left here is 14x. And what this amounts to is 14. And I'm going to divide both sides by 14. X is 1. How's that? Okay. So what I'm mostly focusing on is I had those two X's on opposite sides, and I want to get them both on one side or the other, and it doesn't really matter. But I'm going to go after, I'm going to move out the smaller one. It's almost like there's 2 boxes to move, and I'll take the small one. And you can take the heavy one. You know what I'm saying? So this is negative 2x. To get rid of it, I have to add 2x. So that goes to 0. And once I do it there, I have to do it here. Let me keep doing these until this becomes clearer, if that's humanly possible. Let's see. Let's do a 7x. There you go. 7x. Subtract 5 equals negative x minus 5. Okay. That's a minus. Here's the equal sign. X is over here, X is over here, major problem. This is the smaller one. This is assumed to be a -1. If you want to think of it like that. That's smaller than +7. This is the one I'm going to target. So I see this one and I see this one. I'm going after the smaller one for the reasons we've discussed. So in order to get rid of a -1, I'm going to have to add +1. Add +1 x to both sides. 7x take, and another 1x would be 8x. The -5 is copied. And this was the work I intentionally did. The -1x, the +1x together make 0. And the only thing I have left is the 5, but notice it's -5. Okay. 2-step problem. Here's the x. I get rid of the -5. I add. 8x. Oh, this is an interesting one. -5 and +5 over here is 0. Do not panic. Most people are afraid to write down the number 0. That's a good number. If you're paying off a loan, 0 is your best number in the world. -5 and +5 is 0. You then divide both sides by 8. X equals 0 divided by 8 is 0. It's a perfectly fine answer. Okay. Sometimes I see people, they get this far and then they sort of like freeze. But that's a number. It's a perfectly fine number. And so then you finish the problem, x is 0. How is this going? Is this going or not going? Anybody want to say?
I think it's great.
Okay. All right, I'm going to do a parentheses one again. Okay. Notice the A is only on the left side, so that's different than the other two, but what we have is this. And so we'll deal with that. This would be 3 times A is 3A minus 3 times 2 is 6, or 3 times -2 is -6, however you like it. I'm going to put my +1. And that equals 4. Well, I made some accomplished getting rid of the parentheses. Now I have 1, 2, 3 terms, and 2 of them are alike. I need to squish them together and call it a single number. So this is 3a. How much is -6 plus 1?
-5.
5 equals 4. This work has got me down to the 2-step problem. And so the 2-step problem, I'm going to get rid of this -5 first. And the opposite of negative is add. And I'm going to add. This is 3a. This is gone. 9. Divide by 3. A is 3. Now, how can they make this harder? Let's say you're okay so far. You can distribute, you can combine, you can do 2-step problems. What could they do to make this a little bit worse? Well, what could they do? Well,
They could apply it to geometry. That would make it
No,
a lot worse.
no, we don't want to do that. I'm
Okay,
still gonna
thank
do
you.
equations. We're gonna do that. Let's see. Well, I suppose they could bring in a decimal. I'm gonna do that. I mean, this, just because there's a decimal here and a decimal here, it doesn't really change what has to happen. The x is multiplied by 0.5. And in fact, the problem we did earlier showed that. So all you have to do is divide by 0.5. Divide by 0.5. So this hits the dust. This is 1x, which is x. And so the answer will appear by this computation. So we're pulling together all the things that we've learned through the course. And so one thing we learned is 1 negative will make the answer negative. But what has to happen is we have to get this a single answer out of this slight mess. And so notice it's 0.5 on the outside, 0.08 on the inside. I know it's negative, so I'm just going to ignore the negative for the moment. Doing this by hand, this would come over 1 decimal place. This would come over 1 decimal place, and the decimal would go here. I think I might have to add a 0. So this problem becomes 5 into 0.80. When I move the decimal, it's 0.8. And so I'm going to bring that up. 5 into 8 is once. 1 times 5 is 5, remainder 3. Bring down. 5 into 30 is 6. 6 times 5 is 30. That's the end of that. So the answer is negative 0.16, and we would write it like this. I was helping somebody yesterday, and they put the answer like this. And the program, I can't remember if it was this course or my other course, the program said, oh, wait a minute, you should really, put your 0 in. And so, but for our example, we needed a negative 0.16. But that's doable, isn't it? I mean, these are all skills we've learned previously. Okay, how's our time? Okay, I found one. 3x subtract 5 equals 11 plus 2 parentheses x minus 6. Okay? The left side is actually okay because it's two terms and they're not like terms. This is an X term, this is a number, and so that's good. And so I'm not going to worry about that for the moment. The problem, of course, is this part. So let's deal with that and get rid of the parentheses. So this is 2 times X, it's 2X. And this is 2 times the -6, that's -12. Everybody okay with that? 2X? And then there's a minus 2 times 6 is -12. So the left side was good, but this side can be improved. And honest to goodness, you need to do it now, not later. The more steps you do with too much of a mess, the more chance of a mistake. So we're going to clean this up. This side's good. The 11 and the -12, 11 take away 12 is what I'm trying to do. This is
Negative 1.
-1. So I've got to copy my 2X and then these two together make -1 and I put them like that. I now see that I have 3X on the left and 2X on the right. And I can't leave it like that or it'll never solve. You'll never be able to say X equals something when the X's are in both places. I'm going to go after this one because it's smaller than this one. If I do the reverse, I end up with negative something, and that's where people make a mistake. So if I go after the smaller one, I would subtract 2X. Why? Because this is considered positive. There's no negative on it. So it's positive 2X, negative 2X, both sides. So 3X, take away 2X is 1X, which we could say 1X or X. The -5 is copied. This is gone because it's 0. What's left is -1. At this point in time, you do whatever's left to be done. And to get the X alone, I have subtract 5 from it. The only way to get rid of -5 or subtract 5 is add 5, add 5. This is gone. 5 plus a -1, 4. Okay. All right. I want to do one decimal problem, and I want to show you a trick. Wow, I've got decimals galore, don't I? Decimal, 4 of them. 1, 2, 3, 4. It depends. It depends on the person if they want to continue to do this problem with decimals. But one thing I would likely do myself if I saw that kind of problem is like, oh, so many decimals. What if I took the entire problem and multiplied by 10? I mean, multiply it head to toe by 10. When you multiply by 10, what that does is shift the decimal out. Now, whether this appeals to you or not, it's kind of up to you. It's just like sometimes people see fractions and they panic. Some people see decimals and they say, oh, I always get those wrong. Well, let's see. If you multiply this by 10, the new problem would be 18x plus, this would be 7, equals, this would be 11x, and this would be 14. if this looks better to you, maybe it was worth it.
Yeah, I can do that.
Can you see the advantage of,
Yeah.
nice and clean, it's whole numbers? So now you have the same problem. You have the 18x and the 11x on opposite sides. I would go after the smaller one. It's not always on the right side, the smaller one, but it could be, and it has been in this so far. But I would subtract 11x, both sides, on the x term, because I want to subtract like terms to like terms. So 18 take away 11x would be 7x. Isn't that right? Plus the 7. Notice how this is gone. And what I'm left with is, don't throw that sign away. It's negative 14. I now took this quite messy problem. It's a two-step problem. I need to get rid of this 7 here first, the single number. The single number, that expression is just something I made up, but it's the number not attached to the x. And so I'm going to subtract 7 here and subtract 7 here. The plus and minus 7 go to 0, so I'm left with 7x. And this is a negative 14 and an even more negative, so you add them, it's negative 21. And then I'm going to hit it by divide by 7, and then x is negative 3. How's that? So you tell me, going back to the original problem, whether you liked my suggestion or not.
I love it.
I personally think it's just, and then I'm like whole numbers, I'm not fighting decimals anymore. And so what I want to do is give you solving equations. I'm going to make you a list. This is the order to solve them in the most efficient manner. Step 1 is to simplify. And I keep saying that. Clean up the mess. That could include combine like terms on each side. That could be one thing. It could mean get rid of parentheses. In other words, distribute. Can you think of anything else? Okay. Step 2. Get the letters on the same side. That's what we've been doing, where the x was on the left and the x was on the right. And my suggestion would be to move the smaller term. So for an example, 3x plus 2 equals 2x minus 1. I would move that one by subtracting 2x to each side. Okay? Once you have the letters on the same side, most likely what you have is that the two-step problem. The two-step problem would be 3x plus 1 is 7. And what I want you to do is move the single number first. first. In other words, the +1, you would subtract 1 to both sides. If it was a negative, you would add to both sides. But do that first, because you have two numbers to get rid of, the 3 and the 1, and the order matters. And finally, number 4, it's just a one step. And all you have to do is do the opposite of whatever there is. So for instance, if it's 3x equals 21, the one step would be divide by 3. If it's x plus 4 is 10, the one step would be to subtract 4. So you do whatever one step is left. And so that's the very last step. So this a fancy word, and I like people to know these things, but I'm not going to test it. It's an algorithm. It's a step-by-step, efficient way to do something. Have anybody ever heard of this? Sometimes you hear it in terms of computers. Anybody heard this word? It's also,
Yeah.
it's also a math word. It's an algorithm. If you do it in this order, you're best off. Can you turn something that takes 4 steps into 15 steps? Of course you can. Do you want to? No. You want to do it in the most efficient way. Does that make sense? And so this order, cleaning up, simplifying each side first. Secondly, getting the letters on one side or the other next. That's number 2. Number 3 is the 2-step problem, where you get rid of that single number, the number added or subtracted on to the x. And finally, the last step is just do whatever needs to be done. Divide or multiply or add or whatever is needed to finish the problem. I don't know. I'm pretty sure I told you the example in an emergency room where somebody was having a heart attack, and on the wall was a 17-step algorithm of what to do to stabilize them. And so literally you do first step, second step, third step. You don't want to make it into 100 steps. You want to make it as efficient as humanly possible. And so the doctor literally goes through each step in the correct order. And that's the most efficient way to resolve, get the person under control. Do you hear what I'm saying?
Yeah.
Nurses here or potential nurses. I literally saw that on a wall. 17 steps to get somebody's having a heart attack, get it resolved as quickly as possible. And this is really the same thing. It's an algorithm for solving equations. You don't want to take 10 more steps than you need to. You want to do it in this order. Does this make sense?
Yeah.
This is what we've been doing all along. Yes. Okay. So I don't recommend going to the emergency room. And on the other hand, I literally saw that happen with the steps. And that's, you really want to be efficient. So does anybody have questions about these particular problems? I think my computer froze again. It did, because I couldn't move it. Okay. All right. So this is your guideline. There's something very similar in the reading, but I think this is as good as you're going to get. So where do we stand? So that's the last section, by the way. And so where do we stand? What I'm going to do, let's see. Oh, yeah, I'm going to stop recording.